Have you ever looked up at the sky and wondered, why doesn't the Earth fall down? It's a question that might seem simple at first, but it has intrigued and puzzled humanity for centuries. It's a question that puzzled people for a long time. Ancient civilizations had their own theories, often involving gods or mythical creatures holding the Earth up. After all, what's holding us up? What keeps our planet suspended in the vast expanse of space? It seems like a mystery, but the answer lies in the fascinating world of gravity and orbits. Gravity is the invisible force that governs the motion of celestial bodies. To understand why Earth doesn't plummet through space, we first need to understand how gravity works. Gravity is not just a force, it's a fundamental interaction that shapes the universe. Gravity is a force that attracts all objects with mass towards each other. This means that every object in the universe, no matter how small, exerts a gravitational pull. The more massive an object, the stronger its gravitational pull. This is why planets, stars, and galaxies have such a significant influence on their surroundings. Think about it like this. Imagine holding a bowling ball and a tennis ball. Which one feels heavier? The bowling ball, right? That's because it has more mass. And therefore stronger gravity. This same principle applies to planets and stars, keeping them in their orbits and maintaining the structure of the cosmos. Now let's think about the Earth and the Sun. The Sun is huge. It's over 300,000 times more massive than Earth. That means the Sun has a much stronger gravitational pull than our planet. So, in a way, Earth falling. It's constantly being pulled towards the Sun by gravity. But wait, if Earth is always falling towards the Sun, why haven't we crashed into it yet? That's where the concept of orbit comes in. You see, Earth isn't just falling towards the Sun, it's also moving sideways at a really fast speed. Imagine throwing a ball horizontally. You give it a good push, and it starts moving forward through the air. What happens next? It travels forward, but also begins to curve downwards towards the ground because of gravity. The force of gravity pulls it down, creating a curved path. Now, imagine throwing that ball even faster, so fast that as it curves downwards, it also travels far enough sideways that it never actually hits the ground. It keeps moving forward, almost as if it's gliding. That's kind of what Earth is doing around the Sun. The Earth is moving so quickly sideways that as it falls towards the Sun, it keeps missing it. This delicate balance between falling towards the Sun and moving sideways is what keeps Earth in orbit. It's a continuous dance of motion and gravity. The Sun's gravity acts like an invisible tether, constantly pulling Earth towards it. This gravitational pull is strong and unyielding, but Earth's sideways momentum prevents it from falling straight into the Sun. This sideways motion is just enough to counteract the pull of gravity, keeping Earth in a stable orbit. This cosmic dance between Earth and the Sun is all thanks to the precise balance between the Sun's gravitational pull and Earth's sideways momentum. The Sun's gravity pulls Earth towards it, while Earth's momentum tries to fling it away into space. These two forces are in perfect harmony. If the Sun's gravity were weaker, Earth would fly off into space, drifting endlessly through the cosmos, away from the warmth and light of our star. Conversely, if Earth were moving slower, it would spiral into the Sun, leading to a catastrophic end as it gets consumed by the Sun's intense heat and gravitational pull. It's like a cosmic balancing act, one that has been going on for billions of years. This delicate equilibrium has allowed life to flourish on our planet. This delicate balance is not only responsible for keeping Earth from falling into the Sun, but it's also what gives us our seasons. The tilt of Earth's axis and its orbit around the Sun create the changing seasons, bringing diversity to our climate and ecosystems. As Earth orbits the Sun, it doesn't move in a perfect circle. Instead, it follows a slightly elliptical path, which means it's sometimes a bit closer to the Sun and sometimes a bit farther away. Combined with the tilt of Earth's axis, this elliptical orbit causes different parts of our planet to receive varying amounts of sunlight throughout the year, leading to the changes we experience as spring, summer, fall, and winter. So the next time you gaze up at the night sky, remember this. Earth isn't just hanging out there, it's in a constant state of falling towards the Sun. But thanks to the perfect balance of gravity and sideways momentum, our planet remains in a stable orbit, allowing life to thrive on this little blue marble we call home.